Welcome, I'm Bill Wake. We're working on a set of tools for dulcimer players. Lately we've been working on a chord chart for mountain dulcimer players. We're very close to the end, but the last thing we have to work on is some chords we list might not be reachable. So the notes are valid, but the average hand or even the above average hand might not be able to stretch that far. So we want to filter those out and then see if we can fix them by raising the low note and moving it up an octave and seeing if that makes it better. And then I think we might move the second note up too. So we'll see. All right. So that first rule, low to high, less than or equal to 5 steps. So take the sample chord 1, 2, and 4. So from 1 to 4 is 5 half steps. And that's an example of a chord that probably more than half can reach, almost certainly more than half, but maybe it's 80% or something. It's getting to be a big stretch. The lower notes are wider apart. You can't tell in our picture, but they are. And, so it makes for a pretty good stretch. I don't know if you could squeak, I don't know if I could squeak a 4.5, maybe, but I think a good rule of thumb, as it were, would be five half steps. Okay. And so let's take one that's not so reachable. Let's take, we had one that came out like 1-1-6. Okay. So 1 and 6, that's far more than 5 half steps. What does that get you to? 6, 7, 8 half steps. Okay. So not very reachable, but, if I move the first one up to 8, 8-1-6, well, that's still not very reachable, but 8-8-6 would be. Okay. And so that would be a preferred form of that. So we would kick out 1-1-6 because it's too big, but we'd keep 8-8-6. So I guess that takes the question mark off my try to move second lowest note. There are chords that will come out that way. In particular, I know we have this G sharp at 6.5 is the only G sharp on the dulcimer. So if it tries to stretch from 1 to 6.5, so 1, 1, 3, 6.5, is that right? G, E, G, no, maybe 1, 1, 4, 6.5, something like that, would be an E chord, but 8, 6.5, 5, I think it is, whatever it would be. Yeah, would be reachable. Now the open chords, that's the ones where one or more of the strings is a 0. Well, if let's take 0-5-4. All right. That's a valid chord. It's got a circle, a triangle, and a square, but the open string might not sound as good as if we put the 7 up there. So 7-5-4 is in some ways a better version. It's a movable chord in the sense that chords with open strings aren't movable, because if you move them, the shape changes. So if it's got all non-open strings, then the shape at least stays the same. It won't always be the same as far as major or minor or whatever, but it's the same physical shape. And there are times where you're playing a chord, slide, 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 gets a nice progression or something. But if you had to go 0-5-4, 8, let's try 8-6-5, 0-5-4, 6-4-3, it's like you're bouncing all over the place. You don't want to do that. Okay. So open chords, the 0-0-6 example proves that we'd be better off moving 2 notes up. Okay. So, in this case, we probably won't throw away the open one because it is a reachable chord. 0-5-4 is very reachable. Because it's only got the distance from 4 to 5 that you have to play, but we'd still like to get the other one listed. Okay, the first case, if it's not reachable, we have to throw that chord out and maybe keep the octave one if that is reachable. Okay, but we had some in, like D, F sharp A had at least one that was like a 1-1-6 or 1-1-6.5. It's theoretically a good chord, but it's not reachable, so we definitely can't keep that. All right. I did a couple things offline. One is I added support for dark mode. So I caught that like last 5 minutes of John's broadcast yesterday, and then I watched the whole thing. But on one of the things that that they did was something I had tried to do and failed at. Let's see if I can find my assets file. Is create these namespaces for your colors. And I had tried to do it with slashes or something. I don't know. Whatever I did was not right. But once you have them, you can just say chord chart.background color. And we used to call it chord chart background color, so it gets a little more unity there. I think that's nicer. And then on a couple of these colors, so for dark mode, I made the background turn black in dark mode with light text, or light with white dark text, in regular mode. So that's really all I had to do, I think. I could probably do these tool background ones, but that most of the rest of them, they're using like green on brown or white on light on brown or whatever. But that definitely changes the look. Let's see if I can get jam log. So, I mean, these already supported it. I didn't have to make any changes. We'd already done something to make sure the foreground text could change, I think. So I used that. Let me put light mode back on just for contrast. I mean, it's almost a bit much, but I don't know. It's tolerable. All right. So I did that, and then the second thing I did was I added a new credits and info, and this is contact info. Mudshark, I put you in there because you've been through this whole journey with me, so thanks for the encouragement and suggestions. Big Futch is the musician who suggested this app. Fiona Potts runs Dulcimer Player News, and then support address if they've got any ideas or whatever for us. So that's new. And then last thing is I just created the stubs for Hammer Dulcimer's chord chart. This is totally not the picture we'll have, but it's just enough to get us started on that when we pick that up, probably today or tomorrow. I hope today, but more likely tomorrow. Okay, let's see. So, I think, is it chord chart that has the shapes thing in it? Yeah. Okay. So we calculate those. We take the factors. We run the permutations. What if the root's on the base? What if the third's on the base? And so on. We throw away any that can't form a shape like that, a shape with that ordering of notes, and then we sort them. Okay, so my anticipation is we're going to take that list and we need to assess, well, the ones that aren't reachable, we want to try some octave stuff on them. And the ones that are open, we want to try some octave stuff on. So something's going to happen between compact map and sorted. Okay, so compact map gives you the minimum notes starting on the left, the lowest note in each string that matches the type we asked for. All right, let's see. I lost my chat. Hang on. Okay. So I think the work will be in here. Oops. Somewhere between the compact and the sorting. I think we're just going to have to try these alternatives on wide chords. So let's figure out a test. How that got there? Okay. Oh, let's see. So we measure the width somewhere. Is that on? That's on chord. Oops. Okay. No. Where was width? Well, I know I'd reached right by it. Oh, come on. Oh, chord shape. Okay. Yeah, chord is the notes, C, E, G, or whatever. Chord shape is which goes with which string. Okay. So, well, I guess I'm going to imagine a new question for it. I think the question we're going to have to ask is, what's your lowest string? And then we can know to move it up an octave. Okay, so now also I have a question. So let's see, go back to our chord chart. So we put these in up on the higher frets. I'm not sure how I don't know how we get to those. Because if I say 1 plus 12 chromatic half steps, I mean, it's going to go back to an E, but we really want it to be the E with the 8. So it's kind of a different plus. I think we can go the other way pretty easily. But maybe we're trying to find out the note with the number, with the name 8 at that point. Okay. But the other one I want to do is ask a chord shape, what's the lowest fret you use? Okay. And I just need to know a string coming back or a string index. And I don't need all the answers. If it's 1, 1, 3, I just want to know one of these. And if I move it, I don't think there's any harm. But if I move the second lowest, I'm trying to think if it's hard to think through the combinations. I mean, if I had 1, 1, well, 1, 1, 6, right? That's clearly not a great chord. Move the ones up. You'll have to move them both up. I'm trying to think of one where if I have 1, 1, 2, I guess I only care if it's closed and the reach is greater than a certain size. 1, 1, 2, I don't need to move the ones up to the 8. I need to reconsider. I just live with it. Now the open ones, the width. Yeah. But I guess one question is, are you an open chord shape? And another is, what's your lowest note? I think that's two questions we have to be able to ask. So let's get chord shape doing that. So nose lowest fret. Okay. Do I make this is probably a sut. Okay. So the chord shape is, let's say, well, 2, 2, 4 is fine. All right. Yeah. And then if I say sut dot, I don't know if I should call it min. I'm going to get a string back. Do I get the string back? What do I get? Oof. I guess I can get the fret from the string number. So I don't know, minimum. Maybe it's lowest string. Well, that's not really right. Lowest fret should be the string 0. Okay. Now lowest fret. I don't know. I'm still fussing over these ints. Like they mean slightly different things. Okay. Oh, we'll get the test failing. Make sure the test makes sense. Oops. I shipped a version this morning. So the ChordShape 224. Yeah, he's figured out. I guess he'll pass. And let's see what he stores. I think it's the 3 frets. I guess it's the frets corresponding to the strings in the 3 frets in string order. Okay. So, wow, come on. I also updated my Mac over the weekend, so finding out stuff, it deleted a couple accounts. I think deleted my Git account and my Apple account from Xcode. Like, thanks, guys, I guess. Actually, I deleted the Apple account and the Git password. Like, what? Why would I want to do that? But all right, he's trying. Okay, so the lowest fret, let's see if we can take frets dot min okay with this comparison. Okay, and the comparison is, I guess, fret 1, fret 2 in we want fret 1 dot index less than fret 2 dot index. Current type int. Why are you an int? Okay, let's say that again. Frets.min by fret. Oh, maybe he doesn't. He wants a bool. Oh. Oh, I want the index where it's the least. Okay, let's try 0 dot less frets dot count. Maybe $0 $1's not so bad here. Fret to bool expects 1 argument, but 2 were used in closure body. I guess he's not picking up the by. Oh. Cannot call a function of non-function type int. Cannot convert range expression of int. Ugh. Okay. Oh, maybe I should use the enumerated thing. Yeah, let's try that. frets.enumerated.min, and now we have n well, it's not index 1, it's cannot convert expression, return fret optional element. Okay, so frets.enumerated should give me, I'm pretty sure it's n and whatever. Enumerated sequence, yes, n and c. Okay, so this should be n1 string 1 n2 string 2 in that. Wow. Well, this part's wrong, so maybe that's the problem. N1, so it's fret sub N1 less than fret sub N2. Take that. Hopefully number fret is enumerated sequence fret dot element. I don't know. Cannot convert value of blank blank to closure result type bool. How would that? That's n copies of the same thing. Very literal. I'm not sure what happens if I just say 0 dot dot less than fret dot count. Do I get a array event? Yes. Cannot find. Whoops. Okay, that sounds like what I want to look around for. Okay, so let's take numbers dot min by this. Okay, and this is more like this. Frets of $0 less than frets of $1. Okay, we know this thing has to have frets, so the min should be a single value. Woof. I don't know. Taking me longer than I want. Okay, lowest fret. We'll get the list of the numbers of the strings. We'll run them through, find the one with the lowest index, and that should be it. Well, I saw John was running his TCR plugin yesterday. Seems like it still needs some work. I had one at one point. I wasn't as nice as his in terms of like popping up somewhere to write a message. But I really wish I could convince Xcode to just default the message when I'm doing refactoring and detect that. But maybe I should wish for them to do refactoring first. But okay, well, I think that passes that. Let's change the numbers around. 4 to 4. Okay, that should now be fret 1. Okay. Actually, maybe 442 would be better, and check fret 2, string 2. And we'll make it 3 just so the numbers don't overlap. Okay, so 0, 1, 2, 4, 4, 3, the lowest fret should be on string 2 if they're all numbered from 0. Yeah, that was nice. I don't know if it was the same one they had for the Java side, but I definitely like that one. It had a lot of options. I don't know. I want that smoothness of operation and having to stop and fill in. I mean, the one I did, I just said TCR check-in or something. I don't know. I don't remember what phrase I used, but I used the same phrase every time. Not so helpful. Although the number of times I go back to look is pretty slim, but it does happen. Okay, that's still good. All right. And then this one is, we want to know if has open string. I think that's legit. I should see what it wanted to suggest there. I don't know, with some intelligence, but maybe not enough. And I'm just going to do the expect directly on this. I guess he can be like that. And this one's a not. And this one. All right, presumably one of these failed and one did not. Okay. Oh, why? That's not good. All right, this one came back false. Yeah. Well, that should be. Let's take our frets dot contains where. I think we can just default this. $0 dot index is 0. So if any fret has a 0, I saw stuff being printed in there. Passing two arguments given D sharp. Oh, it's doing the parameterized stuff. Okay, yeah. Alrighty. So that has the answers I'm looking for, I think. All right, now a chord chart. I seem to have lost. All right, so I think we want to say all right, I'm not sure which one's the easier one to start with, but and I don't even know like how am I setting this up? Well, I suppose I got to set up a tuning and a fretboard, but I don't really want to. But there's no way to do an octave test if you don't. All right, so it's got to come after permutations, and I guess it's got to come after compact map, because if the notes aren't on the strings, there's no way to modify it. So something comes in here. Maybe this is a function on ChordShape. If highest fret is above 5, try to move the open string. Well, it's really, I mean, even 054 is a weird one. I mean, it's not that it's bad to have it there, but 754 ought to be there with it because just the closed shape is helpful. So I think for open ones, even if the reach is, well, can we get an open one with a reach that's too wide? I guess we could. If it was 016, then you tried to make it 716, it's still just not reachable. So, yeah, I think with the open chord, I guess with the open chord, we want to move the open note and see if the width is acceptable. And then we want to move the second open note if there is one, and try again. I guess the reach is acceptable is the question, not the width. It's very easy to mix up width and reach. Width counts the 0, reach does not. For some chords that don't have zeros, it'll be the same. Okay, so I guess who I'm asking is ChordShape. I want to ask it, do I care if he's reachable or not? I guess I'm going to have to filter by reachable at some, like maybe after I get everything, I'll filter it. But I want to know if its width is too high. I want to move the lowest note up and then the second lowest note and ask it for what? Oh no. Okay, let's take this out. Go back to ChordShape. Forms chord with octave with lowest note and octave higher. Is that a thing? Okay. So I don't know the fret name for that fret, I guess. That's a problem. And he's not going to know it because he doesn't know the board. He just knows the frets. And just the frets that are being used. All right. Well, let's make a sut. Okay, let's take a variation of this. Okay, let's take our let's take a 166. Right away I can't answer it. Okay, so I want to say sut with lowest fret higher, altered. And then he should be a chord shape. I may have to give him a fretboard to make it work. He should be a chord shape for, this should be 10. And I don't know, we'll keep the same name. Lowest fret altered, lowest fret jumped, lowest fret octave up, octave higher. It could be said to be inverted. Maybe just up an octave, up octave. Octave up. Inversion might be the right word. Although it's really a chord being inverted. Okay, because you take a chord and you invert it, you take the low note and you raise it an octave. So I think that's actually pretty reasonable terminology. So that inverted equals that. Okay. Well, it's not really the root because it could be like CEG. The first inversion is EGC because we raised that C and up. But if you take the inversion of that, you get GCE. You know, so they just keep working their way up from the octave. Inverted is a chord shape, and now what is he? Value type chord shape cannot have a stored property that recursively contains it. Okay, how about a function inverted? He's probably going to have arguments anyway. All right, and let's return self. I mean, I could pass it a function that says given a fret, what's the fret an octave higher, and he would have to know the fretboard to really answer that question. Okay. Fret 1. Well, okay, that's not really right either. So fret 1 goes to fret 8, but the fret numbers in here are half steps. And I'm beginning to think I maybe should pull that out as a concept, because you see these ints and you just don't know, oh, that's a string number. Oh, it's a count of half steps. Oh, it's the name of a half step. But anyway, to raise it an octave, you raise it 12. So that would go to 13. He's still going to be wrong because he's 10. Okay, so wait a minute. Fret 1. Oh. I don't know where this came from. So 13, 6, 6. I was thinking fret 6, but that's not really, well, fret 7 is 12, so 11 and a half is 6 and a half is 11, so it's 10. No, that's 13. This is fret 10, and this is fret 10. Okay, so that's why he's so hard to reach, because 1 to 10, 10 half steps away. Well, that's actually 2 then. And 14 and 10. 10. So if you've got 2, 10, 10, and you invert it, the lowest note is 2. He jumps an octave is 12, is 14. Sometimes doing this kind of thing can make the reasoning a little more clear. Okay, let me run that test again. Yeah, I think we do. They're legit shapes, and sometimes they're nice. I mean, just in terms of moving your hand or something, they can be very handy. But other times they're just kind of awkward. Like I said, if you're moving a shape down, 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 it's very easy to move it. If you got to go shape and then open and then shape, that is trickier. I guess you would keep your hand open and lift the thumb or something, but they're perfectly legit chords, so I would keep them in. But could I just add the two inversions blindly? Yes, I think so. And that might be the way to go. And maybe the inversion only counts. Well, I guess it's the two lowest notes. Yeah, that might be the way to go. Okay. Did you fail for the right reason? Inverted XYZ goes to fret 14. Huh. Okay, XYZ, I guess, goes to 4 4 10. That's not right. 2. Where's 4 coming from? Something's messed up. 2 10 10 should go to 14 10 10. Okay. Let's run that again. Yeah, that would simplify the logic, wouldn't it? We would just expand our pipeline to say, you know, inversions and then filter. Okay. Expectation failed. XYZ equals 14 10 10. Okay. I guess, yeah, that failed. That's right. All right. Now, I don't know. Yeah, I guess I want to have some function that you give me a fret and I'll tell you that fret an octave higher. Um okay. Let fret conversion equal fret in. Okay, so fret dot index. Come on, fret knows these things. Index name and type. I guess we'll assume the type is the same. I'm just going to put a prime on the name. Index and what do I call it? Style? Type. Can I enter type of closure parameter? Oh, sure. Oh, no wonder you couldn't tell me anything about it. Okay. Fret of fret. Cannot find fret in scope. Okay, let's put. Okay, so I'm going to pass a raise octave in there and give that. Is that the way to do it? Do I have to put parentheses somewhere? Yes. Okay. Oh, he should still fail. Okay. Yeah. Yeah. No, I think the chord shape does the inversion. That sounds right to me. You know, that's what we're doing with chords. So I think it's a little funny, but it's probably okay. All right, now this is just returning self again. It should just fail with as it did before, XYZ, XYZ. Okay, but what I'm going to do is put a prime on there. So X prime, usually prime kind of means an octave higher, or they use numbers or something, but it's usually a way. Argument passed and it takes no arguments. Yeah, come on. All right, so I guess now we're going to use this thing. We're going to find the lowest fret. The string with the lowest fret. Chord shape with lowest fret. Maybe this is lowest fret string. Okay, so take the lowest fret string, and now I guess we're going to take the chord shape of frets. We're going to take the frets, and then we're going to do a map. And then if no, I guess we're going to take zero dot dot fret less than dot count dot for each. I still want to do a map. Let's use throws or raise. Yeah. I feel like I'm doing something wrong on this enumerator type. Map over range. Maps over a sequence's elements, but isn't a range considered a sequence? Maybe it's not in there. Well, okay, I'll do this again. Array of 0 to fret count dot map. Okay, well, what am I going to do? If $0 is lowest string, return raise octave of frets sub $0. Otherwise, return frets sub $0. Okay, so now I have the new frets, and we're going to return chord shape of new frets. Do I have to say frets? No. Okay, cannot find chord shape. Okay, find the lowest string, map each string to either itself or raised an octave, and that should be array of fret. Yep. Okay. And we'll work on this. I think we can try the question mark operator. The ternary. I'm expecting it to pass, by the way. I should have said. Oh, okay. Oh, is it just next prime? Yeah, I think so. 12. That's a good question. I mean, the board stops at 10 just because that's usually big enough. Well, I guess the thing is, if its width is too wide, I mean, so 10, like if I go down by my maximum count, right? I think, I've lost my, well, I got it here. Okay, so if I have 10, 1, 2, 3, 4, 5. So if I have, I guess the result has to be a reasonable width. So if it's more than 10, it's not going to be, and these always only go to 6.5. So there's always one note at 6.5 or smaller. Because the octaves are treated as being the same, although there are dulcimers for which that's not true, but those people can work it out themselves. So I think to be a reasonably reachable chord, I don't think you can be higher. 6.5 to 10 is already kind of on the far side. So I think we're okay. And even if we had one that came out to 11 that was still good, I think it would show up in the list, but it wouldn't be drawn that way because the drawing is based on the notes. It doesn't really know the chords. So I think we're okay either way. All right, let's try that run again. Oh, it did pass. I did run it. Okay. All right, let's refactor a little. I don't know. I like this formatting. I think it will get redone when I change. But so if the back to declaration, one too many of these. Okay, so if this is the lowest, we're going through the strings. If this is the lowest string that we identified above, we'll raise the octave. Otherwise, we'll take the fret that's there. And I'm only doing one because then we can take the result of this and try the inversion on that, and the next lowest would go up. Okay, and if we did the third, we can't do it the third time because that will guarantee that the last note is above the above the octave, above fret 7, so that won't be good. Okay, let's make sure that's green and then check it in. Okay. Okay, so ChordShape's not making a judgment. Chord chart. So he has the given shapes. I guess if we do inversions again. If we do inversions, we're going to have a list of things. Okay, so inversions. Inversions applies to a chord shape. Yeah, I guess that's still a chord shape thing, right? So, all right. The name is finds all inversions. And we'll do something related. Okay. I think we're going to pass that function in. Yeah, set.inversions with raise octave. And then we expect the result to be equal to an array Okay, let's put this in with two different different values, at least a couple. 2 plus 12, 8. Okay, well, we should get the inversions back. Okay. Oh, Eric, welcome. All right. I guess we'll put the real answer in here. So, okay, so you should get the original one back. 2, 8, 10. Then we should raise the 2 to 2 plus 12 and give it a prime, 8, 10. And then we should have the first and the last. Let's see. So got a picture somewhere here. So to find a chord, you got to have a circle, a square, and a triangle. And so we have something that already generates the possibilities. So like 2, 3, and 4 is a possible one. But we also get we get some that are not really reachable. So I can reach from 1 to 2 to 4. I can't reach from 1 to 2 to 6. Okay, and so what we're going to do is say, hey, what if your reach is too far? Well, actually, we're just going to say we're going to make the inversion. So the inversion says take the lowest note, move it up an octave. So 2 goes to 9, and then look at 9, 5, 2, or whatever it is, and then take that second lowest note and raise that an octave. So now it's 9, 5, 9. And 9, 5, 9 might be more reachable than 2, 5, 9. I guess that won't, but the depending on the values, it will. Now, I guess the question is, are we keeping these? I guess if they're reachable, we'll keep them. If you could stretch your hand far enough to get them, then they're worth it. But you could have one that's not really reachable to start with, and then when you do the octave thing, it's really not any better. Mostly if it's just like exactly the odd distance away, just kind of like halfway in the middle. If you can't reach half an octave, then, you doesn't matter if it's going up half an octave or down half an octave. All right. So I think we've got nothing raised. We got the first 2 raised. And then, this one is that. That one's raised. This one's raised, and then the original. Okay, so inversions, and he's gonna look a lot like this. But he's going to return an array of chord shape. Okay. So let inversion 1 is self dot inverted by raise octave. And then inversion 2 is inversion 1 dot inverted raise octave. And then we're going to return self inversion 1, inversion 2. Oh, declaration, something unhappy. Oh. Trailing commas, I thought I put those in. Oh. Now, I keep having to look at these flat map things. They deprecated one of them after I went and learned it. And okay, normally I use flat map to get rid of, to turn an array of array into just an array. Is that still legit? Okay, it works, but flattens array of array into a single array. Okay, I hope that's not the one that's deprecated. And then you have compact map, discards nil values. Okay, well, we don't have any nils. Okay. All right, that passed. Okay, so I'm going to check that in. All right, so ChordShape calculates all inversions. And that here. Okay, so now now we got to do the work in chord chart, I think. Okay, so one thing is chord chart. Okay, somebody's got to provide that the function we called raise octave, and I just made up a test version here that just slaps on it goes up 12 semitones and slaps on a tick. But the real one has to be related to our fretboard. Okay, and fretboard, if you recall, comes in lots of variations. So here's this one. Here's diatonic that adds a 6+, where this one just had a 6, and here's one that adds a 1+, and so on. So I think we're going to have to, fretboard is going to have to say, I'm going to raise it 12, and then I'm going to look in my fretboard and see if I can find it. Now I think he can do a kind of a fallback and he could just add 12 and add a tick like I did if he doesn't find it. And maybe that's good enough. I mean, realistically, we're doing these in a way that 0 to 7 is sort of 0 to 6.5 is sort of the first octave, and then 7+ is the first half of the second octave. And if you have a 0, you're going to have something, every number here is going to have 12 higher up until the last of them. So 5. So 0 through 5 get their 12 higher, and then otherwise we don't. But on most people's dulcimer, if there's a 1+, there will be an 8+. I do know people, including kind of my main teacher at this point, he has dulcimers. He put in the 8+, long before people were putting in the 1+, really. But he played a lot of tunes with fiddle players, and if you play an A and you play Mixolydian tunes, you need an 8+ to do it. But most of them don't go low enough to get a 1+ in there. So he just has the 8+. And he likes the sound better on the low notes without the 1.5, because if you're sliding from one note to the next, you don't want to hear that extra note, the 1+ note. But that he's unusual. He's the only person I've seen that's done that. I've seen other people. I saw people that put in a 4+ fret, and maybe it was just on the middle string. I'm not sure. And I've seen people that put a 1+ on the middle string, but not anywhere else. They have that's really a very custom approach, and I'm not going to worry about them. But in general, if there's a low note, there's going to be a note corresponding an octave higher. So, well, we're not going that high, but 1+, there will be an 8+. And the chromatic ones have them all, so they don't have to worry about it. Yeah, I think kind of knowing, well, I really don't want to try and show beyond fret 10 because our stuff is already wide enough and most of the action is in the first octave anyway. So I think if you just said, to raise an octave, you will put, you'll go up 12, and if you can't find that, then we'll make a modified one. But my expectation would be that it does not happen. So I would use that tick approach. And if you had fret 9 up an octave to fret 21, I'm going to make it be 21 5 prime regular, just on the assumption, well, mostly on the assumption it won't happen. But if it did, it would sort of be arguable as to being reasonable. Because really, like when you get in that second octave, you're almost, I mean, honestly, I trained myself to see that as, the first octave moved up, so I can kind of use anything I know about the first octave to do the work, but you don't have to do it that way. All right. Yeah. So I think our raise octave function is the next thing. We want to say, given a real fretboard, how do you raise the octave? And let's define that. And I think that's on, I think that's on fretboard, isn't it? We're going to ask for, I guess we're going to give it a fret. I mean, that's what we have in our chord shape, right? The function takes, the raise octave function takes a fret and produces a new fret. But we're going to do that in the context of a fretboard, and he's got his own rules for that. Okay, so where's a fretboard? Okay, so can raise fret and octave. Okay, and so set is, let's take fretboard, name, diatonic 1 plus 6 plus. Okay, and if we give it, and I want to take a fret that's on the board, I did diatonic 1 6, so let's take 1 plus. I guess I didn't look at it closely enough. It's this. Okay, fret 3 1 plus a half should be equal to, the fret should be 15, and then this is 8 plus, and he's still half. Okay. Okay, that'll get us through the test failure. One, two, three, 1. Okay, and he's going to come back 1 plus. Yep, fret 3, 1 plus half. Okay. Now these, I think we're going to have to just do a scan and see if we find it. So let's take frets dot index. Well, is it a find? First index of fret. No, it's first index where? Half steps per octave, which better be 12. Yes, okay. Okay. And then we'll add a test that checks when the thing is not found. Okay. I guess I'll work on that. Raise fret. Raise, let's say raise octave generates new fret if not found. Okay, so let's take this one. I don't know why it's being weird. All right, so we'll take this one. All right, he should be plus 12 is 23. He's not found, so we're going to do the tick approach, and he's still going to copy that on the assumption it's valid. If it were there, it would be the same. Okay, good. All right. Well, if fret not equal nil, then return this. Otherwise, we're going to make a new fret. And actually, that's going to be a lot like our little test here. Fret index plus 12. Yeah, so we'll generate it off the fret we were given if we don't find it. So this is half steps per octave. And if it's not nil, return it. Otherwise, generate a new one. Comparing down, oops, index. Well, this can be done by fret, so we'll do that. Fret dot raise octave. So fret. I'm just going to kind of do an extract. I guess that's fretboard. Maybe that belongs over here too, but let's one at a time. That might be a one-liner now. Well, I can flip it too. If you don't find it, just raise it an octave. Yeah, that's. This is another one of those places where musicians have developed this very, I don't know, idiosyncratic or inconsistent approach. You know, I think we'd have been far better off if we named these 0, 1, 2, use chromatic numbering and call this 0 prime and the next one 1 prime or something, you know, just to say it was an octave higher. It would help on some things. Maybe it wouldn't help everything. I guess if you're comfortable adding 7, you know, you can get somewhat the same effect. But there's two naming schemes going on, and I think really we're going to use the one on the fretboard if it's possible, and otherwise we're going to fall back to this one. Mostly I don't think that'll be triggered, but we have the tests for it, and that should be okay. All right. Well, let's take a break. We'll come back. We'll figure out the permutations from the inversions, and then we'll get those in, and then we'll add a filter that takes care of making sure they're reachable. All right. So 3 or 4 minutes, and we'll be back then. Welcome back. All right. So I think we're to the point. We've got all the pieces needed to convert a chord shape to its set of inversions. We've got the function on fretboard that does the fret to fret conversion, the raise octave method. And then we've got the place it's going to go. We're going to do compact map, generate the inversions, and then we'll filter them. All right, so let's add a test. Well, okay, let's check that this thing gets the inversions. So I think what's going to happen is anybody who called set.shapes, do we have very many? Maybe that's the only one. Okay. Let's add the inversions. Okay, so 002 is going to 702. And we're going to add them and not worry about the reachability yet. Okay, because 702 is probably not a reachable one. So that moved the first one up, and then we move the second one up. 702 goes to 772. That handles this one. 054 goes to 754. And then 7511. All right, and I'm using the knowledge I have of the we're adding 7 because we're doing an octave on the diatonic scale, not an octave on the chromatic scale. These are the fret names, not the fret numbers. Okay, not the half steps. Okay, so 754, 7511, 200 goes to 270, and then 277, 234 goes to 934, goes to 9104. Okay, 234, 432 goes to 439. And then goes to 4109. It's a lot. Our sorting may trick this up. But we'll let it go. Okay, so 432, 439, 4109, then 450 goes to 457, goes to 1157. Yeah, I'm not quite sure if our sorting, I think our sorting uses the index, so it's probably okay. Okay, 457 goes to 450 goes to 457, goes to 1157. And then I think we're back around. Yeah, that's the starting one. Okay, so it should have an even number of shapes, right? Or three times the originals. 1, 2, 3, 4, 5, 6. Well, 103 to 120 is 17 plus 1, 18. Okay, so 6 times 3. So that sounds right to me. The test will fail. I guess we'll peek at the sorting. Sorted by frets. That's okay. Interesting. Not the failure I expected. Something is a nil. $11. Fret. With the name. Well, what's this test doing? Or who's calling it? Finds all shapes. Oh, shape is right. Okay, if it comes back nil, we only go up to fret 10. So this is looking up the fretboard. If the fretboard doesn't have the fret, yeah, let's just ignore the ones over 10. I think that will be the effect in any case. But 1157, I mean 457 is a chord in that first octave. It's perfectly reachable. It's fine. 1157, I don't know if that's even reachable. And I don't really want to get chords that are too far out. I don't know. It's not unreasonable. Do I have any others that are above? I don't think so. Well, we'll get through it and then decide if it's a problem or not. I mean, I could make them go. I don't know. I could go by chromatic steps or something. We'll see. Okay. 002 054. I don't know if I can. 002 054 200 234. Oh. 432. No 439. Oh, I don't think I've implemented anything. Yeah. Okay. Get there. All right. So coming in here is map foo in. Let's make sure the type of foo should be It should be a chord shape, I think. Yes. Okay. So we're going to map these to $0 dot inverted by I don't know how I say these. Can I say fretboard dot raise octave like that? Instance member cannot be used on type fretboard. Did you mean to use a value of this type instead? Is it? It's not this, is it? I know I've struggled through this before. Reference instance method as function argument. I can always wrap it in a closure. Item dot did it. Item dot did do it. Is that what I not? I thought that's what I did. Fretboard dot raise octave. Instance member fretboard. Dot did do it alone. Functional element goes to that. Foo equal foo. Create an instance foo dot a. That's normal. Something like this. Let x equal foo dot a. The type will be foo to string to nothing. It's a method of returning closure for the function a given an instance of foo. Well, oh, undo that. I think we want fretboard, lowercase. Fretboard of raised octave. He should be array of chord shape. Cannot convert value of type blah to closure type fret. Oh. Array of chord shape. Okay. Why aren't you complaining? Now, wait a minute. But inverted returns chord shape. Sorry, inversions is what I should be calling. Okay, so I take these. Now this should be array of chord shape. There we go. Now we need the flat map. Can I do it like that? No, flat map. Flat map of hashtags. What? Hashtags is that? Do I have to call it on the whole thing? How ugly. Strings.flatmap of hashtags. Oh, hashtags is the function. I think I just want to do flat map of $0. Okay, so are you now array of chord shape? Yes. Okay, and then dot sorted. Take that off. Okay. Yeah, raise octave is a function on fretboard. He's a function. This thing wants a function of fret to fret, and that's what that fretboard raise octave is. At least I hope, because it's supposed to pass at this point. Guess it didn't blow up. That's progress. Okay. Is this really the expectation? 002 054 200 234 270 754 prime. Okay. Where's 232? What's 232? Wait a minute. 432. Okay. 002 054 200 234 270. Yeah, okay, that's out of order. I guess both those are out of order. Two 270 277 432 439 410 The sorting's working good. 450 457 702 772 754 75. Well, wait a minute. 754 754 prime. Okay. 7. Oh. Seven five four prime 772 934 910 4 prime 57. Well, I think that just tells me I should just do this, and shapes not found in the fretboard. Notes not found on the fretboard. Get this. I don't think it's going to be an issue. All right, make sure I've got these spelled right in the right order. Very promising, though. It makes me think our inversions and all that stuff's doing its job, which is good. Now 1157, is that a... I don't think that's going to be reachable. I think most of these won't. Oh yeah. Okay. Diatonic fretboard. So this helper is my thing on here that's defining them. Yeah, it does not. The helper we have in here does not handle the prime arguments. Okay, I'm gonna take a cheap way out, I guess. Okay, if $0 ends with prime, do something. String has no member ends with what? Start index. I have to do start index. And there starts with, isn't there? Starts with. Really? Has suffix? Okay. Is there a strip suffix? No. Oh, that gives me the character. Remove at. Removes and returns the character. Okay, if it has a suffix, grab the fret name, remove the last character, use it. Otherwise, just use the character we gave you. And then, is there a plus? Dot. Raise octave. Can I use mute? Oh, thank you. And I'm going to assume it's there. All right. Now, we haven't done the filtering, but we'll do that next. And the good thing is, I mean, I like the approach that we're generating all these. We're not worrying about open or not open. And I think the reach covers that. So 054 would be a long stretch, but reachable. Okay, what's the matter? Where's those 11s? Are they no longer 4 prime 5 7 4 prime 5 7 9 10 4 9 3 4 7 7 2 7 5 4 prime 7 5 4 7 0 2 4 5 7 4 5 0. What's missing? 0 0 2 0 5 4 2 0 0 2 3 4 2 7 0 2 7 7 4 3 2 4 3 9 4 10 9 4 5 0 4 5 7 7 2 7 5 4 7 5 4 prime. I don't see the difference. There must be something on those too. Ugh. Yeah, if it has a prime ticket, has name, should be true. 0 0 2 0 5 4 2 0 0 2 3 4 2 7 0 2 7 7 4 3 2 4 3 9 4 10 9 4 5 0 4 5 7 7 0 2 7 5 4 7 5 4 prime 7 7 2 9 3 4 9 10 4 4 prime 5 7. Ugh. Okay. Actual is dot shape. So actual is array of chord shape. These are chord shapes. I'm sorry, I'm not seeing the difference here. If $0 has suffix okay, I'll just look at these. Well, maybe we'll look at the sut.shapes too. I suspect there's something about the chord shape that's not right. Have I done this right? So we take off the tick, we look up the fret name, and then we raise it an octave. So he should find it. I don't think the hidden stuff shouldn't be any different. Yeah, let's run that test. Well, I don't know. I'm going to have to go through a bunch of junk, aren't I? 1, 2, 3, 4, 5, 6, 7. Where's the first prime one? The actual, oh, did I pass that in? Yeah, he should. I think he has the tick, so that shape is being called on the answer that we're expecting. So he turns it into the fret and he does raise octave. But if you print that fret, raise octave, where's raise octave? Fretboard at raise octave. He puts the tick back on if he has to. He calls fret.raise octave, and that puts the tick on. So that doesn't seem right either. Oh no, this is the desperation move. This is I've found a fret that's not on my list, so I'm just going to get the frets per octave version of that. Okay, so I'm going to skip. Oh, I'm going to go. Maybe I should just print. I'm going to break inside here. Okay, so what's $0? 4 tick. Fret name should be 4. He has it removed. Okay. Okay, he's fret index 7 for regular. Okay. He's producing I may be wrong, but this is producing a chord shape. So he's all right, but so that returned that, but let me grab this whole expression now and print that, which is what he's going to return in a moment. He's going to print 19 4 prime regular. So that seems right. He was 7, he's now 19. Okay, let's continue. Nineteen 4 prime regular, another 4 prime. Okay. Now, why didn't you stop where I asked you to? Oh, I guess I didn't see it there. Okay, let me run again. I should stop here and look at actual. We know the names are right, but maybe he didn't do the plus 12. I don't know. None of these involve pluses, so that's kind of helpful. Okay, so and this is going to be big. 17, 0 through 17. Okay. Okay, so 0, 0, 2, 054 2004 sorry 234 270, and the index is wrong. Oh no, he's right. 7 is 12. 12 7 octave. I have to say the matching on that thing could be a little more. Okay, so I mean I got a 12 and a 12, both named correctly. That's fine. I guess we're going to look for this 11s, the 4 primes. 4 5 7 4 10 9 7 0 2 7 5 4 7 5 4 prime. He's 19, he's 4 prime, and he's regular. That sounds the same to me. Okay. Can I get more information on this? Yeah, let me try show. Go back. Let me continue. Okay. Down here, do this, do show. Down. The actual 002 054 200 234. Where's the 4 primes? 754 prime. 4 prime 5 7 is shape of that. Well, that doesn't really tell me what he really is. Oh, if I open him up. 002. He's just got the names. Fret 3 elements. Okay. 7 5 4 prime 12 9 19. Okay, let's see slot 13 up here. 7 5 4 prime 12 9 19 7 5 octave regular regular. Octave regular regular. Those look darned identical. And what was the last one? That was 4 prime 5 7. 4 prime 5 7 19 9 12 regular regular octave. 19 9 12 4 prime 5 7 regular octave. Those look frets are comparable or equatable, right? We did not make them equatable. I thought comparable. Let's make sure that's equatable. Yeah, I don't, okay, we'll do it a different way. Let's do, 0 dot dot less than actual dot count for each Okay, so now I can do, I'm just going to put a print. Value of int has no. For each. Okay, well, we're going to go one more, and then I'm going to map the string, the fret number, fret names. Okay. Why? Oh. I guess I should have run just one test. Okay. Finds all shape permutations sorted. 8. 450, expected 410, 9. Actual index is 450, expected is 410, 9. Do I have 410, 9 in there? I do. Am I misreading? 410.9 after 439. 439. 457. Oh, my ordering is wrong. Oh, gee. Oh, I keep running everything. It's amazing how the eye cannot see things sometimes. Okay. Until 410.9. Okay. Oh, I made my actuals. Okay. Or my expecteds. But that's okay. This one's going away. Oh, goodness. How many times did I count through that list and check them all? Golly. Yay. Okay. So add all inversions for each chord. All right, let's run the app once, make sure that doesn't blow up. Although, in a way it could. Those prime frets are not good things. Okay. All right, and we're encroaching a little bit here. I think I got to put a little border on this stuff. We just didn't have the index doing that before. Okay, so 439 is 432. Yeah, but the lists are all there, so that's promising. Okay, I'm glad that didn't blow up. All right, now we're going to modify this same test. Heaven help us. All right, the question is, are these chords reachable? Okay, so the ones I'm going to say are not, well, anything with zeros is probably reachable. 270, let's look at that. Okay, so I said 1 to 4 is 1, 2, 3, 4, 5 half steps. 2 to 7 is much more than 5. Okay, so if it's greater than 5 half steps, it's going to be ignored. All right, so 270 is not reachable. 277 is not reachable. 432 is fine. 439, so 3 up to 9. Yeah, that's way, I mean, this was adding 3. You might be able to add 4 in some case, depending on the half steps, but you're not going to be able to add 3, 4, 9. So 3 to 9 is 6 full steps or minus a couple. Okay. 439 comes out. 450 is great. 457 is great. 4, 10, 9. So 3 to 9 wasn't feasible. 10 to 4 to 10 is not reasonable. 702, that's not reasonable. 754, 754 prime. 7, 5 up to 11. So 5 to 11 is a 6. That's not going to work. I expect the primes to go away. 772, that's not reasonable. 934 is not reasonable. 9104 is not reasonable. 4 prime 5 7 5 to 11. 7 8 9 10 11 to 5 6 to 5. Now that's just not reachable. Okay, so I'm going to say reachable shape permutations, and this is going to fail. Getting it to fail is usually not too hard. All right, I'm hoping I might take extra 5 minutes if we need it, but I think we can get this one pretty quickly. We have ChordShape has reach. Okay, so that's the width. Okay. Chord chart. So we'll flat map them and we'll filter with dot reach is less than I think less than or equal to 5 half steps. Yeah. So 1 I assume this comes back 1, 2, 3, 4, 5. That's fine. Okay. And we'll have to pull a constant out for that. Okay, well, that worked out nicely. I guess that's doing the right stuff in the first place. Okay, so this is a bit to think through. Okay, take all the factors, switches all the chord combinations, 135 or 137, do the permutations, get all the shapes of those chords, map them to generate all the inversions, flat map it, and then filter those for reach less than 5. Okay, and then run. And we'll refactor a constant out of this. Okay, well, we still got to worry about this width a little bit. 002, 0, so 002, 200 is the flip. 234, 432 is the flip. 457, 754 is the flip. And then the extra one, or the open ones, 054 is really the only one. 200 is already kind of open like that. And 450. That is right. Okay, so a C chord, 012, 650, 657. Yeah, so 756. Yeah. So raising the octave on that was good, made a nice tight little chord. But if you can't do that, you can still do the open 5, 6. Okay, that is looking pretty good. Okay. So we need some padding. Let's run the test and check that other one in. And let's see if we can find out where the padding goes on those lists of things. So chord. Mountain Dulcimer Review. And you can still take those chords up an octave, but we're just not generating those names for you. So that's all right. Where did my file? Okay, so each chord has one chord view. Fretboard view, text of this. Well, I'm not sure it's there. And a computation to calculate the distance using varying fret sizes. Yes, that's true. Yeah, I mean, for some people, I mean, I guess you could put your hand, you know, can you reach 1, 2, 4, you know, or 4, 2, 1. Okay, there we go. All right. Well, I don't often get to time these perfectly, but that's a wrap on this feature. And tomorrow, just a tiny preview. We're going to take up this hammer dulcimer chart. It's different. You know, they have a very different thing, a lot more notes and more choices. But we're going to produce something like this and put our diamonds and circles and stuff, you know, on the little line that represents the string going across. So we'll pick up there tomorrow, 2 to 4:30 Eastern time, 7 to 9:30 p.m. UTC. I'll get this checked in offline. Thanks for joining. I'm so glad to have this feature. That's great. Thanks. Good night.